Capro-X uses microbes to convert organic compounds in acid whey, which is a byproduct of Greek yogurt production, into specialty chemicals, biofuel feedstocks and animal feed additives. So, first of all, can you explain what acid whey is and what yogurt makers are currently doing with it?
Right, so yogurt in New York, a lot of it's strained yogurt, so Greek yogurt and skyr, and because of that straining process, if you wanted to take a gallon of milk and make yogurt, you'd be left with maybe a quarter of a gallon of milk, and you'd make 3/4 of a gallon of this acid whey byproduct or waste. And in New York, they're basically treating it like a waste and trucking it off site, feeding it to livestock, spreading it on fields, and ultimately taking it to wastewater treatment plants. So it's a cost for them and a logistical expense just managing off-takers, people able to just pick up these wastes whenever they're available. Acid whey is the ideal feedstock for fermentation. It has water, lactose, minerals, and vitamins, perfect for bacteria to grow. Our fermentation is able to make a number of different products, particularly fatty acids. So we make butyric acid, caproic acid, caprylic acid, and today these chemicals are sourced from palm oil used by specialty chemicals industry for the flavor and fragrance markets in particular. We're also looking to expand our opportunities by doing non-GMO, natural new products with ours as precursors. So we're making esters and triglycerides like MCT oils and looking to sell those to the specialty chemical market also.
Is it a two-stage process, a one-stage process? And also the bacteria that you're using, did you just stumble across them, or are these kind of genetically engineered bacteria?
Nothing is genetically engineered, everything is naturally occurring.
Right.
So about a decade ago, the lab that I worked at during my PhD decided to try some research doing this fermentation process, and they collected a bunch of bacteria from a lot of places and hoped to strike gold in some microbiome, from a wastewater treatment plant to a swamp to a stream, and just put whatever was in there and make it work. So nothing's genetically engineered, it's all natural fermentation, and it is a two-step fermentation process. So we break down the complex lactose into lactic acid, and then that lactic acid then gets broken down and rebuilt in the second stage into these longer chain products, these fatty acids.
Okay. So what about your business model? You know, how do you make money?
Right. So a lot of our early customers are really interested in a subscription model. They would, especially with the nascent age of our technology, would have trouble investing in a company like ours to deal with a critical waste like this. It's much easier to go through a subscription model and let us guarantee that we'll take the waste and take the risk, and let them forget about waste treatment and let them just think about Greek yogurt production.
So how does that work in practice? So are they kind of shipping this stuff to some central location, or are you supplying some kind of equipment enabling them to process it on site? Or?
Right, so we have packaged treatment systems. So our initial goal is to target smaller customers so we can scale and develop our technology with essentially units of shipping containers, drop them off on site, and start operating them and just charging our customers per gallon of acid whey that we treat. So they'll just hook up a line to our process and we'll take care of the rest.
Okay.
As we scale, we'll go to the larger dairy byproducts streams from cheese and milk processing. And at that point, the business model will change less from waste treatment, more to biorefining, and that'll require more partnership with those kinds of customers to make sure that we can get those kinds of byproducts, because they're not really waste at that point. They're actually commodity, low-value products.
Okay, so can you, I mean, you've already touched on this, can you tell me a bit more about the team around, in your business, Capro-X, and, how you got started?
Right, so this technology was initially developed at Cornell, and Capro-X spun it out from the university, and we've been around since 2017.
Okay.
And the team consists of me and the co-founder of my PhD advisor, Lars Angenitz, and we have a team of 2 chemical engineers and a handful of mentors in the fermentation, animal feed, and specialty chemical space.
Okay, so how have you funded the business today?
So far, we've been very lucky to fund it on non-dilutive grants. So we've got a National Science Foundation grant and a Nexus New York grant from New York State. We recently won a Fuse Hub commercialization competition, and that's actually funding our first pilot scale-up at a Greek yogurt company in New York.
Okay, so that was my next question really, what's the timetable, what are the key milestones?
Right. So we just installed this and are operating this first pilot at a Greek yogurt company. They've been nice enough to offer us space and acid whey, and they want to evaluate the technology to see if it's a solution for them. Our next step is to scale about 20x next year, and at that same facility start treating about 250 gallons of acid whey a day, and then in 2 years, after doing a lot of optimizations of that in those 2 years, we'll scale to a commercial facility.
Well, okay, so give me a sense of the size of the prize here. I mean, is this something that the likes of Chobani and Danone would be interested in? Because, some of those companies have already invested in solutions to deal with acid whey, or is this more targeting mid-tier to small companies?
Right. Actually, the companies haven't invested that much in handling acid whey. They're able to use their co-op partners to take a lot of that acid whey back, but a lot of it's handled by trucking. So we do have an opportunity to capture a lot of the Greek yogurt market by applying our systems to those kinds of large producers.
I mean, don't some of those producers kind of recover the whey via reverse osmosis and then recycle the water, or maybe feed it into biodigesters?
Actually, no. So acid whey is particularly difficult compared to cheese whey. Because of its acidity and mineral properties. It clogs up all the reverse osmosis systems. So while there are some small projects doing that, the industry at large isn't able to concentrate those acid whey byproducts that they do for cheese and milk. They do have some digesters, but to our knowledge, it's really not a widely practiced activity for getting rid of acid whey.
So basically, you're saying even the very biggest companies could absolutely be interested.
Is that even the biggest companies are still trucking dozens of trucks of acid whey offsite every day.